So for our actual notes, I'm going to take it straight from the actual textbook. This is page 543, lesson 9-1 in the algebra textbook. The first section we're going to look at is graphing quadratic functions. Here we're going to learn some key characteristics about quadratic functions, how they look on a graph, and in another video you'll also figure out some ways to do quadratics on the calculator. So the first section says characteristics of quadratic functions. Quadratic functions are nonlinear and can be written in the form f of x equals ax squared plus bx plus c, where a is not equal to 0. Anything that I highlight, except for that, anything that I highlight, I definitely want you to copy down into your notes. So anything such as this information here, I want you to copy this into your notes. The highlighted words or vocabulary words, you can use those for your flashcards, and I also would jot some of those down in the notes as well, but those will most likely be a part of the notes. So back to the reading, sorry. This form is called the standard form of a quadratic function. The shape of the graph of a quadratic function is called a parabola. Parabolas are symmetric about a central line called the axis of symmetry. The axis of symmetry intersects a parabola at only one point called the vertex. So here, if you look at the graph here, this blue line is the actual parabola. It's a U-shaped line. The axis of symmetry is this dashed red line here. The vertex contains a point, x comma y, that actually tells you what the axis of symmetry is. This point here, which we'll talk about later on, is called our minimum. So let's figure out what that minimum is. And don't forget, all of this here in this section under key concept, you need to copy down in your Cornell notes. When a is greater than 0, the graph of y equals ax squared plus bx plus c opens upward. The lowest point on the graph is a minimum. When a is less than 0, the graph opens downward. The highest point is the maximum. The maximum or minimum is the actual vertex. So what we just learned right now is this actual vertex is an important point. It tells us not only the axis of symmetry, but it also tells us our maximum or minimum point. I want you to write this down in your Cornell notes. When a is greater than 0, the graph opens upward. If it lets me copy it correctly. And then I also want you to write down when a is less than 0, the graph opens downward. For some reason, it's making me highlight the entire line, but I only want you to copy that section right there down. When a is greater than 0, the graph opens upward. When a is less than 0, the graph opens downward. And this is a lot harder than I thought it would be. So now, let's take a look at the actual example. Here they give us the graph of a parabola. It says use the table of values to graph y equals 3x squared plus 6x minus 4 and state the domain and the range. So here they give us a table of points, 1, 5, 0, -4, so on and so forth. And all of these points are here. Then you connect the dots and create the parabola, which is a U-shaped form right here, this blue line. So after we graph the ordered pairs and connect them to create a smooth curve, the parabola extends to infinity, meaning these two arrows here mean that this line keeps going on forever and ever. Our domain, which is our x values, will keep going from negative infinity to positive infinity because these lines are going to keep spreading outward and outward. So that is going to keep going to negative infinity and that one's going to go to positive infinity. The range is y such that y is greater than or equal to -7. So here, looking at your y values, our graph does not go below -7. Our y values are greater than -7, so when we write our range, it's y is greater than or equal to -7, because -7 is the minimum value. This guided practice problem number 1, I do want you to copy down into your spiral. In your spiral, I want you to copy down guided practice number 1, and I want you to do the same steps I just used on this example to solve for the guided practice number 1. It does not give you a table of values, but pick table values for x, and you can get the values for y. So for example, if you pick x as 0, if you plug in 0 for x here, you would get y equals 3. Keep doing the same thing and create a table. Plot the points, and I want you to give the domain and the range.